Okay, all right. So now we are going to discuss about organic chemistry. So in basically, what is organic chemistry? So organic chemistry is a chemistry of compounds of carbon genetic bonded with hydrogen, oxygen, nitrogen, and halogen. So I'll discuss you about carbon genetic bonded in upcoming lesson. So first things you need to remember is organic chemistry means it's a compounds is a chemistry of compounds, you know. It's a carbon genetic compounds, no, it's a carbon genetic bonded. It means the compounds which is uh, carbon genetic bonded with hydrogen, oxygen, nitrogen, and halogens. Okay, so let's go to hydrocarbons. So hydrocarbons means basically hydrocarbon is made up of it's made of carbon, and it's made of carbon and hydrogen, you know. So it is made up of carbon and hydrogen. So in hydrocarbon in hydrocarbon it is divided into two depending groups, you know, two depending groups, that is saturated hydrocarbon and unsaturated hydrocarbon. So what is saturated hydrocarbon? So saturated hydrocarbons simply in which carbon atoms are bonded, means carbon, this is a carbon atoms, so this is carbon atoms are bonded with single covalent bond, you know. This is bonded with a single covalent bond. Okay, so single covalent bond. So just remember this in your mind is that a saturated hydrocarbon are those carbon which is bonded with single covalent bond. Okay, so it's in which carbon atoms are bonded together by single covalent bonds CC only. You can say like that. Okay, so uh, uh, so uh, and back to unsaturated. Unsaturated are, it is bond with double, you know, it is double bond or triple bond. This is double bond, this is covalent bond. Okay, so this is double bond, or you can say or C 1 2 3 this is a triple bond. Okay, so triple bond, so like that. All right. um, we'll discuss this more clearly in next part. So saturated hydrocarbons are less reactive. This is less reactive. These are less reactive and stable, you know. This is less reactive and stable. Okay, this is less reactive and stable, and this is more reactive but not stable. So unsaturated hydrocarbon are more reactive but it is less stable. It is less stable, more reactive but less stable. You can say that less, but less stable. It has stability but it won't be stable like the saturated hydrocarbon. Okay, so less stable, let's say. All right, so um it has only one group. It has only one group, that is alkane. Okay, so it has only one group, that is alkane. This is the alkane. So saturated hydrocarbon are alkane, and it is more solute. So no more solute dissolved. So here is no more solute dissolved. No more solid, solid, uh, no more solid dissolve. Okay, so no more solid dissolve. Okay, so this is alkene and alkyne. Okay, so alkene and alkyne, alkyne, alkene and alkyne. You can say like alkene or alkyne, and then so it is so here more solid dissolve. So in saturated, no more solid dissolve means there won't be solid. So solid means so so let's take one example, like there is water in glass and you put little sugar, so that little sugar is solute, and the water is solvent, so just imagine that in saturated hydrocarbons there won't be like, there will be less solute dissolved, less solute will be dissolved like water. So but in unsaturated hydrocarbon, more solute dissolved means more solute dissolved, my more solute. Okay, more solute dissolved. Okay, so more solute dissolved, simply like what to say, more solid dissolves, okay, so let's say in um, uh, I wanted to take one example, like you put chocolate inside milk and it gets cream, so that is more solid dissolve. So you put solid is chocolate, more solid into milk, so that's the example of more solid dissolve. Okay, so uh, this is saturated hydrocarbons. Okay, so in first we have discussed that uh, in first hydrocarbons have two dependent groups, that is unsaturated and saturated. So in saturated, there is a single covalent bond, so single covalent, simply you can mark that this is um, a single covalent bond, right? This is a single covalent bond and less reactive and stable. So this is less reactive and stable, so due to sigma bond. So carbon atoms are bonded by the sigma bond, so these atoms are bonded by sigma bond, which is very stable, strong and hard to break, means sigma bond are stable and it is hard to break. So I'll just create I'll create one example. So here you can see, so C, this is a single bond. Okay, so it's a at 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 so here, so this is methane, CH4. This is CH4, means how, means it is one C and four hydrogen. Okay, so this is CH4. So here, here is a 4 sigma bond. So this is sigma, this is sigma, so this is sigma. So this is very stable and this is strong and it is hard to break. You cannot break these saturated hydrocarbons. Okay, so saturated hydrocarbons are alkenes. Okay, alkanes. Okay, ALKAN, yes, alkanes, do not get confused. So here I'll create one example. So here is also hydrogen, hydrogen, hydrogen. Okay, so 1 2 3 4 sigma bond, so 1 2 4, and again 1 2 3. Okay, so this is also the saturated hydrocarbon. So how many carbon are here? So here carbon 2. Okay, let me do this. So here is Here is carbon 2, and here is how many? 1 2 3 4 5 6. So here is 6 hydrogen, C2H6. Okay, so sometimes in a large structure, it will take a long time for you to count hydrogen. So there is one formula, just to remember. So this is called a general formula. Okay, so this is general formula, and here is CnS2 CnS2n plus 2. So how? So N, so Cn, so how many carbon are here? Here is 2 carbons, so you can simply do uh, you have to only count carbon, not hydrogen. So just do carbon 2, and here is, so 2 into 2 means 2 into 2 is 4. 4 plus 2 6. So directly you can apply this formula. So CnH2n plus 2 is a general formula of alkanes. In this is saturated hydrocarbons. Okay, so here also same things apply. So here is, we have one carbon means, so now 1 into 1 plus 4 hydrogen. Okay, so like that, do not get confused. Okay, so so back we study about alkanes. So alkanes have single covalent bond, that is sigma bond, and which is very stable and less reactive and hard to break. Sigma bond, it is hard to break. Okay, so here in unsaturated hydrocarbons, alkene means, okay, so unsaturated hydrocarbons are the compounds in which carbon atoms are linked together by multiple bonds, either uh, double, single, or triple bonds. Okay, so here unsaturated hydrocarbons, uh, hydrocarbons are bonded together by double covalent bond. So double covalent bond, you can even say this is pi bond. Okay, so double covalent bond means this is pi bond. So, and it contains two hydrogens, so this is two hydrogen. All right, so let's do one example here. Let's do some examples, not one. So this is C. So here is this is a double covalent bond. Okay, so this is double covalent bond, and here is two carbon. So here is already two hydrogen, so you have to put, so remember, in one carbon it contains four hydrogens. So here also you have to, either you can put it like this also, or put it down. So here is table 1 2 4 hydrogen. So like this, here also you have to put some hydrogen. Okay, so how many carbon are here? Here is two carbon, and here is how many? There is four hydrogen. Okay, so two carbon, four hydrogen. So so look, so here is also one example. So this is, so here is three hydrogen. Okay, so you have to put here two hydrogen, because here is already two. So this is two hydrogen you have to place. So here is three hydrogen, so you have to place one hydrogen over here. So here is one hydrogen means you have to put three hydrogen. Okay, three hydrogen. So three hydrogen. So how many carbon? Carbon three. 1 2 3 4 5 6. So 6 hydrogen. Carbon 3, 6 hydrogen. Okay, 1 2 3 4 5 6, 6 hydrogen. So this also have general formula. So you don't have to count a whole hydrogen. Here is the general formula is, here is CnS2n. Okay, CnS2n. So you can even say like that, here is two carbons, so 2 into 2 4. So here's three carbon, three sorry, here, yeah, this is 3. Okay, so 3 means 3 to the 6. All right, so can, so this is carbon 3, so 3 into 6, you can select that 3 into 6. All right. So this is the unsaturated hydrocarbon. Okay. So previously we discussed about alkenes. So unsaturated hydrocarbons includes alkene and alkyne. So in saturated we study about alkene. So it has sigma bonds and it is very stable and less reactive. But unsaturated hydrocarbons includes both double and triple bonds, and it is less stable but more reactive. Okay, so all alkene, there is only pi bond, that is double bond, but in alkyne there is triple bond or single unsaturated hydrocarbons which contains a single triple covalent bonds, that is C triple, that is uh, this is three hydrogen. Okay, this is three hydrogen atoms. So this is three hydrogen atoms. So um, let's take one example. Okay, so this is sorry so mm, let's take one example. So here is three covalent bond, so it two carbon atoms. So here is already three hydrogen, so you have to just add one. Okay, and here just add one, so this is stable. So here is how many carbon? Here is two carbon and two hydrogen, two carbon and two hydrogen. Okay, so let's see here one example. So here is a triple bond and this. So here's already three hydrogen, so you just need to put one, and here is one, two, three, and this is stable. Look, one hydrogen and three hydrogen already stable, but here is you need three hydrogen. Okay, so here you need three hydrogen. So here three carbon, and how many hydrogen are here? Here is four hydrogen. Like one, two, three. Uh, no, one, two, three, one, two, three, CH. So this is absolutely incorrect. Okay, so sorry for this. I'll just create one example. So here I got a little misspelled. So here, uh, so here, what you have to do is well, let's just C and C. Okay, so C. All right, so C, and then after one, two, three, and C. So here you have to add one, so it's already stable. You do not need to put another hydrogen here. Okay, okay. So here, so here you need two hydrogen, just two hydrogen, and here you need three hydrogen. Okay, you need you need three hydrogen. Here you need three hydrogen. So how many carbon are here? Is four carbon, and how many hydrogen are here? One, two, three, four, five, six hydrogen. Okay, so six hydrogen. So here it has also general formula like we did previously. So the general formula is CnS2 CnS2 S2n minus 2. So let's do practical here. Okay, over here is two carbons, so 2 means 2 to the 4 minus 2 is a 4. Okay, what's a minute? Okay, so here is 2 to the 4, 2 to the 4 minus 2 means 2. Okay, exactly. So here is 4 carbons, 4. So 4 to the 8, 8 minus 2, 6. Okay, so like this we need to count. All right. Okay, so talking about common system of nomenclature of hydrocarbons. So there are common system like how we will name those hydrocarbons. So so here are these two types of nomenclature system, and just let's go to definition of nomenclature. So it is defined as a system, it is a system of assigning proper name, so assigning proper name to a particular organic compound, a specific organic compound, on the basis of scientific rules. So there are the scientific rules, so how we will name those organic compounds, in proper name. Okay, so these are the number of carbon atom, and this is the root word. Okay, so this is a root word, and this is the number of carbon atom, and this is the notation. This is 1 2 3 4 5 10. Okay, so when there is one carbon, you have to remember this root word, methane, meth, eth, prop, butane, and octane, non-indicant. So this is one of the most important, part of chemistry, the organic chemistry. So if you do not remember this, then you won't be able to name those organic compound. So here we have second nomenclatures, so this is the IUPAC, system of nomenclature, and this is the latest improved and worldwide accepted model of nomenclature. So like that, similar fact. So while naming, find the root on the basis of the number of carbon present in the hydrocarbons. So let's examples. We have here CC. So this is the it. Here, two carbon is present. Here. So after finding the root word, join the suffix ane, eane, or yane. So this is the saturated hydrocarbon, alkane. So uh, it must be ethane, ethane. So this is ethane. Okay, so here ethane. All right, so ethane, and the suffix are also called primary suffix. So this is the primary suffix ane, ane, and YNE. So example, CS3SCC propane. I had already discussed this. So propane. The system of all organic compounds on the basis of their structural formula adopting IUPAC rules is called IUPAC name. All right. So here a condensed formula, common name, and IUPAC name of some hydrocarbons are given below. So condensed formula is this, and the common system butylene, propylene, acetylene, and IUPAC system butane, propene, ethene. Okay, and in easy to remember at a glance. So alkane, alkyne. All right, so this have I had also discussed about general formula. So this is the general formula, CnS2n plus 2 for saturated, and for unsaturated CnS2n, for unsaturated CnS2n2. Okay, so let's discuss about homologous series. So when a member of class related chemical compounds having similar structure are arranged in order of increasing molecular weight, means when the number of class of related chemical compounds having similar structure are arranged in order of increasing molecular weight, they are said to constitute homologous series, means order of increasing molecular weight. Okay, so each member of such series is called homologue of the adjacent members. Okay, so adjacent member, for example, the alkenes like methane, CS4, ethane, C2H6, propane, C3H8 form a homologous series in which each member differs from next by CS2. In other words, a homologous series is a group of organic compounds which has the same functional group, but two successive members differ by CS2 group. So CS2 each and look, CS2 group, CS2 group, right? So here we have a homologous series of alkyl, and alcohol is listed below. Alkenes, CS for methane, CS3, CS3 ethane, propane, and here when adding alcohol, methyl alcohol. Okay, so methyl alcohol when adding mm, uh, ethane with alcohol, it gives ethyl alcohol and propyl alcohol. So I'll discuss how this methyl, this is alkali radical. Okay, so this is the alkali radical or alkali group and functional group. So alkali group, the hydrocarbon unit derived by the removal of one hydrogen atom from alkane is called alkyl group or alkyl radical. The name of alkyl radical is written by replacing the ending ane of the alkane with at YLE. It is general formula CnS2n plus 1. So so alkane, alkyl radical. Okay, alkane. Okay, so I just wanna give one example, butane. So meet it prop but and let's say pentene. Okay, so I'll just uh, pentene. So here I have pentane, and how I'm going to, so the molecular formula of pentane is C12345 and like this. This is the H. So how many H we have? We have on the formula C and S2n plus 2 means here we have 5 7 means here we have 12 12 carbon. So what happened here is removal of one hydrogen atom. So here is C5 and as 12, I guess. Okay, so let's go 1 2 3 4 5 6 7 8 9 10 11 12. So 12. So in alkyl group it will be C5H11. You can even use this formula, carbon 5 and how many carbon, 2 plus 11. Okay, so you can even use this formula. So this is the uh, pen uh, uh, pentyl. Okay, pentyl. So this is a pentyl group. Okay, so uh, so here are the alkali group and functional group. So functional group, it is defined as an atom or group of atoms radical which determines the chemical behavior of organic compounds. Chemical behavior. So alcohol, ether, amine acid, aldehyde, ketone are some examples. So here is the calculation. So when an alkali group combines with a functional group, an organic compound is formed. So compound is formed. So CS3 alkali is a methyl plus alcohol gives CS3 plus OH means methyl alcohol. Okay, so methyl alcohol. So let's do one example. So we have already known about it. This pentyl. You know, this is a pentyl. PNTYL. Sorry, PNTYL. I just made doing PNT pentyl, PNTYL. Pentyl. Okay, so there is pentyl group. uh, Pentyl group. Okay, so I'll just so now while let's add one functional group. Okay, so what what we're gonna add means we're gonna add ether, no, amino. So C C, sorry, so C 1 2 3 4 1 2 3 4 5. Okay, so C we can make let's do like this. So here we add C5H11 uh, plus plus we are going to add amine. Okay, no, amino. Sorry, we're gonna add amine. So NS2. NS2 gives CH5S11 NS2. So this is pentylamine. You can even say pentylamine. So this is the pentylamine. Okay. All right. Let's do a few examples of those acids. Here we can do okay. So I'm just gonna add what to add? So butyl. Okay. So BUTYL, butyl plus acid, carboxylic acid. So carboxylic acid. So butyl, we have butyl means 3, no, butyl means 4, so 4 carbon, 2 3 4 carbon. uh, just you can do like this, I guess. 1 2 3 1 2 3 4. So this is a 4 plus carboxylic means COH. So this is COOH. So we have 1 carbon, can COOH. Okay, COOH. COOH gives it gives C4 C4 to N means C4H5 COOH. So this is the butyl acid. Okay, so BUTYL, butyl acid. So this is the butyl acid, and then well, we'll be having so what will be the complete structure? So C C C C C, 1 2 3 1 2 3 1 2 3 1 2 3. So here will be one removal, means here we can just add you can just add COH, maybe, or you can just create like C and COOH, like H H H H H H H H. Okay.